Okay guys, let's do some sideways shifting or horizontal shifting or what they call phase shifting. See, a sine or a cosine graph, rough little quick sketch here. Oh, come on. It's going to keep going, forever. It's going to keep doing the same thing over and over and over again. So when you shift this graph sideways, either direction, when you shift it either direction sideways, it's hard to really tell what happened because you're adding or subtracting a sideways movement to something that's infinite. It's kind of like that old concept where, like, if you have infinity and then you add 1 to it, don't you still have infinity? So the thing is, with this type of graph, since it is infinite in both directions, if we're going to move it sideways, what we talk about is something called a phase shift. And we're going to move this thing to the left pi over 2 units. We are. The same tricks you know about shifting graphs have not changed. This thing is still going to shift pi over 2 units to the left. But the way we keep track of our work is slightly different. Since you can't really tell where a graph starts or stops, we kind of build that in to our answer. Now you might go, what does that mean? Follow along. Once you get the rhythm of this, it's really not that bad. And just so you know, I am going to only graph one period of this for the first couple examples, then I'll show you 2 periods. So let's begin. First things first, I kind of made a little bit of a mess here, so I'm going to get rid of some of this stuff, get it out of my way. And I do like the words phase shift, but I'm going to get them out of my way for now, because the first thing I want to do is I want to say, well, this thing has not been amplified. That's a 1. The period has not been changed. That's a 1, right? These are 1s right here. So no monkey business there. The only thing that I'm really adding to this is the phase shift. So if I were to find the period for this thing, I would say the period is 2 pi divided by 1. That guy, that's my B. And then I would say, oh, so it's a period of 2 pi. Yeah, it is. And in fact, the increments have not changed. I haven't changed the way I find increments on this stuff. But here's what I want you to kind of keep in your mind. Since this graph is infinite in both directions, we're going to say that it starts normally at 0 at the origin, and then all the information, the x information, is between 0 and 2 pi. That is what the normal period on this looks like, right? Well, here's where this part's going to come into play. When we see that we have a phase shift incorporated into the problem, we're going to handle it this way. See, this is where my graph would normally start. This is where my graph would normally stop if I was just going to graph one period of this function. Here's how we apply the shift. This is called applying the shift. I know my graph normally starts at 0, but this time instead of all the information just being x, we put the phase shift in the center of our inequality. And now I'm going to solve by doing this. I'm going to take away pi over 2 here, pi over 2 here. I'm going to take it away from that. What that does now is that 0 take away negative pi halves is negative pi halves. And then 2 pi take away pi halves is 3 pi halves. So here we go. This is still, well, it's now, not still, this is now where my graph is going to start. whoop, what the heck? This is now where my graph is going to stop if I'm going to graph it over one period. And if I was going to count off my increments, I would still go up to the top here. I'm going right up to the top saying times 1/4. I still do that for every graph. And then I'd say, oh, so my increments are pi over 2. Let's draw this graph. So normally when I graph stuff, I have my, come on. I hate when that does that. Try it again. I have my y and my x. But you're going to notice I drew my coordinate system a little bit different because I want to accommodate what I see. See, I see that I'm going to be counting, my increments are pi over 2. Okay, so every dash is a pi over 2. But I start at negative pi halves. That's where my graph is going to start now. That's my start. I'm going to go up pi over 2 units. That would put me right here at 0. Then I'd go one more. That would be pi over 2. Then I would have 2 pi halves. Then I would have 3 pi halves. And that would be where I stop. Remember, I'm graphing one period of this function. Now, of course, you want to go back and you want to reduce. I don't want to call it 2 pi halves, so I'm going to get rid of that. I just call it pi. And then I'm going to sketch this graph. I'm going to use red. And remember, this graph, its amplitude is 1. So it's going to go as high as 1. It's going to go as low as -1. And remember, always mark these values for me. If you're not marking all your quartiles and all your highs and lows for me, I notice it. I got to. That's part of my job. All right, I'm graphing a sine function that has not been flipped. So it's going to start on the line, but it starts where? Where it's been shifted to. That's my starting location. Then I go above the line. Then I go back to the line. Then I go below the line. Then I'm back on the line where I would stop. And here we go. I'm going to try my best to draw this smoothly. I always wobble on the downside. Oops, I missed that one. Heck, come on, I can do a little better than that. Maybe. God dang it. Okay, there we go. There we go. That is one period of this function. And like I said, if they wanted me to do 2 periods of this function, I could extend it in either direction. But when they ask me to do a phase shift, it is so customary to graph the first part, like here's my start, here's my stop, and then you would extend it this way. That's just the custom, that's, polite mathematics. But that is only one period of the function. Let's try another one, but the trick is here, since this thing is infinite in both directions, if you're going to shift it sideways, that's where this little doohickey comes in. We haven't done this before. We haven't shown that step because we haven't tried to shift anything sideways till today. So let's try another one. But if you need to, pause it, take a picture of it so you could jot it down for notes or whatever you want to do. Whatever works for you. So here we go. Let's look at another one. And this time it's a cosine. But this time my shift is a pi over 3. But I wanted to make sure you guys knew this before we start anything. I'm not messing with the amplitude or the period yet. I'm not. I don't want to mess with either of those yet. Will I? Yes. But, so the period for this thing, normal period, 2 pi divided by 1, I'd say, okay, it's at 2 pi, right? And if I wanted to, right now, I could say times 1/4, boom, boom. I get my increments, my counting pieces. But don't jump the gun. Don't be too quick. When I say those are my increments, I'm going to count by pi's over 2. Yeah, but where I start and stop is going to be a little bit different this time because I have a different phase shift. So let's go get some more information about this graph. So I know that it normally starts at 0, and I'm going to leave out a step that I did in the last one. normally starts at 0, and then the information between it, see, I'm just going to plug in the phase shift right now, and then this thing would normally stop at 2 pi, all right? That's what it would normally do. Now, since I am going to apply this shift right now, I'm going to have to do it to both ends of this inequality. Then 0 plus pi thirds, I get pi thirds. My graph is going to be between positive pi thirds and, now here's the thing, if you're adding 2 pi plus pi thirds, etc., they're going to always work in improper, so I'm just going to show you, they might just change this to 6 pi thirds, right? So it's got a common denominator, and then you go 6 pi thirds plus a pi third, that would be 7 pi thirds. So what am I talking about? There's my start, and there is my stop. If I'm going to graph this for one period, all right? And my increments are gonna be pi over 2. So what I'm trying to say here is, this is the toughest part about shifting something sideways. See, I am going to start at pi over 3, but then I have to add pi over 2 units. I can't do that easily because they don't have common denominators. So what might be helpful is if we think about it as, well, I could rewrite everything with the same denominator. I hope you see where I'm going with this. So for pi thirds and pi halves, the common denominator would be 6. So what I'm going to do is I'm just going to say, hey, this starting value could be called 2 pi sixths. It could. And then this stopping value, if I'm going to do the same thing, would be 14 pi sixths. Now, of course, if I have to mark stuff off on my graph, I'm going to reduce numbers. I am. But what I'm trying to say is then my increments, I could count them off as 3 pi sixths. And then all I have to do is count. So, here we go. If I'm shifted, this is a positive number, right? When I draw my graph here, come on, there we go. I'm going to show you what I'm going to do. I'm not going to give myself very much room on the negative side of the x at all because I don't need to. That would be 0. But see, here's the deal. I'm going to be counting in terms of sixths. See, every dash on the x-axis here has to represent the same exact number. So if I'm going to go 1/6, this would be 2 pi sixths right here. And then I have to add my increment. So I'm going to go 2 pi sixths, that would be 3 pi, 4 pi, 5 pi sixths, 6 pi, 7 pi, 8 pi sixths. I could reduce that. I'll come back and do it later. 2, 11 pi sixths, and then 1, 2, 3, 14 pi sixths. See, where do I start? I start at 2 pi sixths. Where do I stop? I stop at 14 pi sixths. And every single dash on the x-axis has to be uniformly spaced. Now, here's what I like to do. It makes it easier on my brain, is I simply do it this way. I count. I don't make it all fancy. I say, hey, if I'm going to make this easy on myself, I convert everything to have the same denominator in this problem, sixths. And then I just count by 6. So that's, let me do this one more time. I'm going to use a color so you can see me count it. That's 1/6, that's 2 pi sixths. 3, 4, 5 pi sixths. 6, 7, 8 pi sixths, 9, 10, 11 pi sixths, 12, 13, 14 pi sixths. And you guys know as well as I do, this number right here is going to reduce to pi over 3. This number right here is going to reduce to 7 pi thirds. So let's see, do I have to reduce anything else in between? Sure I do. This one would reduce to 4 pi thirds. So we're supposed to go back and reduce things. But you know what? I'm going to leave that one as my guide. I'm going to let that thing guide me, and then I'm just going to draw a clean one up here. Watch. I'm going to go up here, and I'm going to say, okay, there's 0. This reaches a height of 1. It reaches a low of -1. And then I'm going to go, there's my 2 pi 6, but I'm going to call it pi over 3. And then I go ding, ding, ding. What did I call that one? 5 pi sixths. 1, 2, 3. I'll call that one 4 pi thirds. 1, 2, 3. I called that one 11 pi sixths. And then I got 1, 2, 3. I got to do that one, and I'm at 7 pi thirds. And that is my one period of this graph. And I included my starts and my stops. Let's do a different color here. I'm going to use blue. What the heck? And it's a cosine graph that has not been flipped. So I don't start on the line, I start above the line. But look where I'm lined up with. I'm lined up with where my graph starts. Remember, that's my start. And then I'm going to go on the line. Then I'm going to go below the line. Then I'm going to go back on the line, and then I'm going to go above the line. And that is where my graph will stop. And I am about to sketch one period of this function. Wish me luck, because I was never a really great artist when I was a kid. Okay. All right, there we go. That's a pretty nice looking cosine graph that has been shifted pi thirds to the right. It's been shifted pi thirds to the right. But here's the thing. I'm trying to specify this. Every dash on the x-axis has got to be equivalent. Its meaning, its numerical count. This one was tougher. Guess what? You're going to run into a couple that are easier and a couple that are tougher in the assignment. This one's tougher, but I'm going to scroll back up to our first one. Look at this one was nice and easy because everything already had common denominators. I didn't want to mention this in the last one, but look. All of this stuff already had common denominators. So it was easy peasy to count this one off. Guess what? Some are easier than others. That one, they weren't the same denominator. So I kind of went through and I made them the same denominator so I could just count. That's all I wanted to do is count it. And then what did I do? I went back and I reduced answers that needed to be reduced. I left ones alone that didn't need to be reduced, and voila. There you go. That one's going to be the harder one. You might have to come back and review this. But let's continue. I want to get all the tricks into one video. Here we go. 2 plus cosine 2x minus pi. So this time I have a vertical shift, so I have a different center line. This time I went and messed with the period because my b value is 2. And I also have a phase shift of pi units, but one thing I did not mess with, that is the amplitude. The amplitude is 1. And let's begin. So I like personally to start with my period, so I go period equals 2 pi divided by b, so in this case it's pi. I could say pi times 1/4, and I could get my increments, or pi fourths, which I may or may not have to come back and get a common denominator. I don't know. Let's see how this plays out. But my period would normally be 0 to pi. But I'm going to put my phase shift in between that. Remember, my period 0 to pi, and then here's my phase shift. So I'm going to move this thing out, and this graph is going to shift pi units to the right. This would be my start. This would be my stop. And I'm going to count by quarters. Okay, if I'm going to count by quarters, I'm going to count by quarters. These guys both have denominators of 1. I could think of this guy as starting at 4 pi fourths. You see, get my drift? And then this guy, where would this guy be? This guy would be 8 pi fourths. That's so I can just count everything off. Now this one I don't think is going to be that big a deal. But here, I'm going to give myself very little room on the negative side of the x-axis because I don't need it at all. In fact, I'm going to be counting by quarters. So I go 1 quarter, 2 quarter, 3 quarter, 4 quarter. That's where my graph actually starts. My graph actually starts at 4 fourths. Now, on this, what the heck? I'm just going to say 4 pi fourths. And then I'm going to count. The next one would be 5 pi fourths. I probably should have made my spacing a little better. Then the next guy is going to be 6 pi fourths. Yeah, because it's going to be kind of tight. Then I'd have 7 pi fourths. And then I'm going to stop at 8 pi fourths. Yeah, you know what? I'm going to expand this just a little bit when I redraw it. Because here's my reducible pieces. That's going to be pi. That's going to be 3 pi halves. That's going to be 2 pi. But I did count everything by quarters. Here, that would be 0. And I got to remember this one's going to have a vertical shift of 2 units. So you know what? Here, I am just going to do this. I'm going to go back up here, and I'm going to redraw it. And when I redraw it, I'm going to put my x-axis down here because I'm going to have 1, 2 units till I hit my good old center line. So there's my center line. And away we go. Let's mark off some stuff here. So that's 0, but I'm counting by fourths. But you know what? I'm going to make them a little bigger when I count this off. So I don't have to. There's 4 pi fourths. There's 4 pi fourths, but I'm going to reduce it. I'm going to call that pi. Then I'm going to go 5 pi fourths, giving myself a little more room this time. Then instead of 6 pi fourths, I'm going to reduce it. I call it 3 pi halves. Then 7 pi fourths, can't reduce it. But this thing stops at 2 pi. Remember, I am just getting common denominators. That's all I'm doing so that I can add, I can just count. Remember, the whole trick is make it so you can count it off. But I'm graphing a cosine. Come on, blue, come on. Okay, here we go. I am graphing a cosine graph, so it would start above the line. It has not been flipped, so I would have to put a mark up here and say it's going to reach a height of 3, my center line's at 2, and a depth of 1. That's as low as it's going to go. So let's go over here to pi, and we start above the line, right? I'm starting at pi, then I go to 5 pi fourths. Then I go to 3 pi halves, right? And I'm simply graphing a cosine graph. Let me try this way. Not too bad. I've done better, but I've done worse. All right, there we go. See, what I'm trying to get in your head is try to make this as easy as possible on yourself. If you see that your starts and your stops, oh, I never labeled that as a stop, starts and stops, if you see that they are not in the same form as your increments, get common denominators. Then all you have to do is count, and then possibly you come back here and you reduce things. You don't have to reduce things that are not reducible, and then you're good. Okay, guys, I got one more example to show you because you're going to see these also where they have everything. You're going to see some that have every little piece of the puzzle. So let's break it down. What am I looking at here? I'm looking at a vertical shift. What am I looking at here? I'm looking at a flip. Right here I have an amplitude adjustment. Here I have a period adjustment. And here I have a phase shift. You get everything in this one. And that's the goal. We have to be able to recognize every little piece of the puzzle and put it together in a graph. So here we go. Let's do my period first, and I should have left myself a little more room, but I didn't. So period is going to be 2 pi over 1/2, and we've learned that fractions are actually our friends, so we have a period of 4 pi. All right, and that means if I take 4 pi times 1/4, I'm going to have pi increments. I am, but I can see there might be a little bit of a hiccup here because my phase shift has a pi half in it. But I'm getting better at this. I know that my normal period on this function would start at 0, and in this case it would end at 4 pi, because that's my period right here. So let's find our start and stop here. So the first one, it starts at pi over 2. It does. But my increments are in pi. You know what? I could always call my increments 2 pi halves. I could. You catch my drift? I hope so. And then that would be an x, and then this would be, well, 4 pi. Isn't that 8 pi halves? Yeah, 8 pi halves plus a pi half. That would mean this thing stops at 9 pi halves. Now, I may or may not have to reduce stuff after I do it. I don't know. It never hurts to have like a preliminary idea where you're going to start. So, heck, I'm going to go down here, and I'm going to say, you know what? This particular graph is going to be shifted down 1 vertically. So I know it's going to go down 1, but let's figure out our increments first and see how gnarly this might become. I don't know. I know I'm going to start at pi over 2. And my increments are in pi, so yeah, this is going to be my strategy here. I'm going to start here at pi over 2, but then I'm going to go 1, because I'm going to add 2 pi halves to that. So I go 1 pi half, 3 pi halves, and I'm going to count by 2s. 4, 5 pi halves, 7 pi halves, and I hope the next one is 9 pi halves because that's where I'm supposed to stop, and it is. So it's just a matter of thinking through how, oops, stop. Duh. I was thinking the word stop, and I meant to write the word start, and then stop. Okay, so here we go. That looks pretty good. I counted everything off 2 pi half style. And everything is equally spaced. Everything looks good. What the heck? I'm going to try and just fit it in on this graph. Let's see if I can do that. I hope so. I am going to grab a red pen. Whoop, come on, red pen. And I'm going to go down 1 unit. Oh, you know what? I'm going to redo that. Down 1 unit. Give myself a little more room. And I'm going to call that thing -1. And I'm going to mark it as my center line. And then I'm going to have to go up 2 units from there. So if I was up here, that'd be +1 because that's 0. And then I'd have to go down 2 units. That would put me at -3. That's the bottom of my graph. So I'm going to go as high as 1. I'm going to go as low as -3. And my center line is at -1. So I've taken care of my amplitude. I've taken care of my vertical shift. I already have my increments marked, so now it's just a matter of graphing. So I'm going to, what the heck, let's do green. I haven't used green. And it's a sine graph that has been flipped. So sine doesn't care. It always starts on the line. So it starts on the line. But instead of going up above the line, it's going to go below the line. And then it's going to come back to the line. Then it's going to go back above the line. Then it comes back to the line because my sine graph has been flipped. And away we go. Let's try and draw this pretty the first time out. I'm doing it in little pieces. It's actually easy. Ah, that's a pretty one. Now, you know what? I remember I said this at the beginning of the video, but I don't have room because I didn't realize how big I would write. If I were to extend this for another period, customarily, you would not mess with your start. You wouldn't. So I would go, 11 pi halves, 12, 13 pi halves, 15 pi halves. I could extend this graph one more period if I want to, but what I'm trying to get at is that would be one period of that function. One period of the function. All right. Now, here's the thing. The very first day we started graphing these, I only did amplitudes and periods. And you might have said, this is not that bad. It's pretty easy. Hopefully you said that. Then vertical shifts. Most people are like, vertical shift, not too tough, I got it. When you start phase shifting, you start getting into fractions. And that's when it gets tougher. So I got to tell you, here, I'm going to show you the assignment. Here it comes. The very first part, I left it in the view there. It's page 157 of your book. Problems 33 through 38. Okay? And all these say graph over 2 periods. So you can see the pictures right here. Here's the answer keys. They shifted it and then they did one extra period to the right. Every single graph they drew, they shifted it and did one extra period to the right, just like I was saying. Usually they don't go right and left side. When you have a starting value and then you have a stopping value, right? But you'll notice here, look, all quartiles are not marked on the book's answer key. That means you still need to mark them. Now this is, in my opinion, this is the toughest lesson that you guys have in graphing. So you'll see that on problem 34 here, I labeled each quartile. I went in and I filled in the blanks for you. But I don't really want to do that for you on every one of them because I want to see how much you trust your own self. You can figure out what the period is. On these, it's all the same. It's 2 pi. And then they adjust the start. So you're going to have to figure out your own quartiles. Now, that's why I'm always in the Zoom room. If you need help, come back and ask. I will help you. But here's the answer key for those ones. Pause it, take a picture of it, but realize they're missing a whole lot of their quartiles. Then, here's the next set of problems. These are 53 to 56. Now, the book does something weird here with the brackets. In problem number 55 and 56, they throw these brackets in there. You don't really need to write the brackets there, but I just wrote the equivalent statement. It's the same as this if you want to. You'll also notice these ones have everything. There's a vertical shift, there's an amplitude adjustment, some of them are flipped. There's everything. Everything you can, that's like our very last example that I did. So here's the thing. On these ones, I actually worked every problem out. So you could take a look at it. There's 53. Now, it's not the best work. I did not have a ruler with me when I did it, but all my markings are there. And these ones all say over 1 period. So this is all 1 period stuff. I accidentally kept going here and I went, oops, duh. They only want 1 period. So there you go. That's 53. That's 54. And then here we go. There's 55. Did not. Oh, stop it. There's 55. Ooh, green doesn't show up that great. And there's 56. Because those ones are the toughest because everything's there. All right, so there's your answer key for the last four. So if you get stuck on any of this, remember, come back to the Zoom room, ask questions, and away you go. Good luck.